Okay, this last problem I wasn't able to get to for in the previous lecture, to keep it under 20 minutes. We have 22.4 grams of a certain salt, and the temperature rose from 24 to 39.3 degrees Celsius. The heat capacity is 1,554 joules per degree Celsius. Now, they gave us heat capacity. We're used to using this equation. But another equation for heat is where we use the heat capacity rather than the specific heat. But you can see that the heat capacity then must be equal to the specific heat times the mass. We use the heat capacity when we're dealing with a system in which the mass does not change. We don't have to add the mass, like we're adding water or a solid sample. A bomb calorimeter, though they only say calorimeter here, but it's whatever type of calorimeter, that calorimeter stays intact. Its mass is always the same. So instead of finding its specific heat and then always multiplying by the same mass every single time you use that calorimeter, if you know the heat capacity of the calorimeter, just plug it right in. Saves you a little time. So we have the heat, instead of using this guy, we're going to use the heat capacity. And you can tell by the units that you're using. You have joules per degree Celsius. There's no mass term here. There's no grams. So we must use T final minus T initial. Sorry, I should have plugged that in. Joules degrees Celsius. T final is 39.3 minus 24. Okay. 39.3. Oh, dang it. 39.3 minus 24 times 1,554. And this comes up to be 2.38 times 10 to the 4th joules. And now, that is the amount of heat that came out per 22.4 grams. That 22.4 grams produced that much heat. So if we take the ratio of them, this will tell us how many joules per gram. We know how many joules per 22 grams, but that's not a normal kind of way of approaching or stating a heat given off per mass. We take this. This comes up to be 1.06 times 10 to the 3rd joules per gram, or 1.06 kilojoules per gram. So for every gram of the substance, it produces 1.06 kilojoules of heat. Now, in this case, heat is neither positive or it's positive or negative. We're just stating how much heat is being given off. Now the temperature rose, so the heat came out of the system, came out of the salt and heated up the calorimeter. But now we want the so it tells us how much this is heat per gram given off. Sorry, kind of put those together. Heat per gram given off. But they want to know the enthalpy. Enthalpy is going to be units of kilojoules per mole. So we have our term, 1.06 kilojoules per gram, and they've told us that the molar mass of this salt is 156 grams per mole. So if we multiply those together, we end up with kilojoules per mole. Now on something like this, you're probably not going to guess that. That's why it's important to do these problems, do as many of the different ones as you can. Now, that's the amount of energy given off, kilojoules per mole, but they want delta H. Delta H also gives the sign. Since it came out of the salt and heated up the calorimeter, it's negative. So you had to put that negative on there. It was definitely exothermic if the temperature went up. So that is the deal.